Hi everyone, I'm Simone Pizzimenti and I work in Communication Valley. This is the SoftFIRE tutorial. During this video tutorial I will show you a possible use case for the SoftFIRE middleware through the definition of an experiment and its actual deployment on the platform. First, we start from formalizing the use case context. For this tutorial, I have chosen a more commercial focused example instead of the classic experiment we had on the platform. That is the case of a company that want to include a testing phase inside the development process of an ERP service. When we have defined all the key elements that will compose this use case, we will map them on the SoftFIRE experiment. In the end, I will show you a live demo on the SoftFIRE platform. An ERP service is an enterprise resource planning service that a company might use to collect, store, manage and interpret data from many business activities. I've chosen an ERP application beside others because I want to be more generic as possible in order to focus on the platform programmability. In this simple service, we have two main components, let me say. The front end used from users in order to visualize and edit data through a web application, and a backend component that comprises the service logics and the database that will store the business data. From this specification we can determine what physical components we need in order to implement that service. From the left picture we can see the server for the front end and another server that will deploy the database backend. Furthermore, we also want to have some kind of security, so we have a firewall gateway. Last but not least, we also need a network topology inside which our service will be run. We can buy all the stuff to have a physical environment for the production environment, but the problem arises when we want to develop a new version of this service without stopping the production version. Without replicating all these components, we can't have a test that perfectly mimic the production environment. Furthermore, we don't want to damage or stop the production data, so we need to find a feasible solution. So the goal is to have a testing environment that simulates perfectly the production environment. We want a fast and easy way to set up the environment in order to focus on the service development itself. And also we want a testing environment that will be isolated from the production environment. So a feasible solution is to use a virtualized environment able to fully replicate the network topology and all the components that compose the service. A standalone solution that uses virtualization technique is not enough for our needs. We want a solution the more automated and easy as possible. So we choose to deploy our testing version of the ERP service inside the SoftFIRE middleware. We can see some benefits from using SoftFIRE. We have a platform that is adaptable, easy to specialize, and also we have the capability of on-demand service premises. So we have to define a network service inside which we specify from high level the network topology, the virtual machine, and the software to be installed, and SoftFIRE will handle all the deploy of the network service. So we do not have to worry about how it will be deployed. Also, SoftFIRE provide generics managers, but if for instance we need a more specific manager, for instance a ERP manager, we can add our own managers to the SoftFIRE platform. Furthermore, with SoftFIRE we can handle easily the scale out of the resources we want to deploy in order, for instance, to stress test our service. Now that we have defined our service, it comes the interesting part. We can use the previous specification of the service to define an experiment that will be uploaded inside SoftFIRE using the experiment manager. In this slide we can see the topology representation of our service. The orange cloud represents the SoftFIRE platform inside which our experiment will run. The SoftFIRE network is isolated from the outer world with a virtual private network. A user that wants to connect to the network has to use a VPN endpoint providing a valid certificate and credentials. In this topology we can see two networks: a wide area network with internet access that represent the DM zeta of the company, and we can see the local network behind a firewall gateway, in which we can see the two main components connected. The front-end server is connected both to the WAN and the LAN, and is the only component of the service that will have access to the internet. Now that we have a clear idea of the topology and all the components, we have to map these components into SoftFIRE resources. we have the server front-end and the database backend that will be mapped into NFV resources. Then we have the firewall gateway that will be mapped onto a security resource. Now we have 2 NFV resources and 1 security resource. We have to define the experiment, and we have to use a language that the SoftFIRE platform will understand. We use the TOSCA language, that is the topology and orchestration specification for cloud application, and this definition written in TOSCA language will be placed inside a CSAR archive. A CSAR archive is a zip archive that have a precise folder structure. We can see that this archive contains 3 directories: the definition directory. Inside we have a .yarn file that represents the the actual experiment definition. We have the files directory that will contain some file required by the experiment. In this case, it will contain the custom network service required by the NFV resource, and in the end we have the TOSCA-Metadata folder that will contain some metadata regarding the experiment. Here we have the experiment definition. The important property are the topology template. We can see all the node templates required by our experiment. We can see first the front-end and back-end network service that will contain our 2 NFV, and we can see the firewall gateway in the node named PFSense gateway. We can see also the name of the testbed in which our network service will be deployed. For this example, we choose the Surrey testbed. We can see in the front-end back-end network service the type, that is the NFV resource, and we can see other property, the SSH pub key that will be used to log inside the virtual machine created, and more important, we can see the file name that will be stored inside the files directory of the CSAR that will contain the custom network service definition. The firewall gateway is deployed using a security resource of type PFSense. PFSense is an open source firewall gateway, and we can see also that we can specify the name of the network used by the gateway. We can see the local network name, that is testing LAN, that we will use also for the front-end back-end, and we can see also the name of the one network. There we can see the content of the TOSCA-Metadata folder that contain 2 files, a metadata.yam that contains the name of the experiment and the date range of the experiment. Using this timestamp, this date, the SoftFIRE middleware will know when the date expired experiment. Then we have the TOSCA.meta that contain information related to the version of the experiment and the name of the experiment definition. In this case, service.yam that I had showed previously. Then in the files directory we have the another CSAR that will contain the definition of the custom NFV resource. Also this CSAR have a similar structure of the previous CSAR, of the outer CSAR. We have the definition directory that contains the custom NFV definition. We have the TOSCA-Metadata, and instead of the files directory we have the script directory that will contain the install script of or ERP service that will run inside the virtual machine defined inside the NFV. The metadata.yam is a little different from the preceding. In fact, there we have to specify the actual images used by the virtual machine, and also there we can specify the VM type, in this case OpenStack. Here we can see the custom network service definition. We can see in the left picture the two virtual network function, that is the backend and the front-end server. We see we have defined some property for both the backend and the front end. We can see that we have specified the network used by this virtual machine, and we can see that for the front-end server we have requested a floating IP. Instead, for the backend we have only requested a local IP. Also, we can see in the lifecycle property that we have specified the name of the script that will be executed once the virtual machine became active. This script will install our service. Furthermore, in the right picture we can see the relationship template property that is used to link two or more VNF. In this case we used this property in order to provide to the front-end server the IP address of the backend server. Now that we have defined all the components that comprise our experiment, we create the archive, and we use the experiment manager dashboard in order to upload this experiment. Now I will show you a live demo of our experiment inside the SoftFIRE platform. We go on the experiment manager web dashboard, we insert our credential, and we will log inside the experiment manager. On the home page we have a list of all the resources make available from SoftFIRE. We can see that for instance we have some security resource. We can use a firewall, a suricata resource or a PFSense. Also we have SDN resource, monitoring resource and NFV resource. Then in the right pane we can see the image available to use inside the custom NFV resource. We have Ubuntu image, CentOS image or Cirrus image. Also we can see a list of all the networks available on the testbed, but we can also specify our custom network. In the end, we also have a list of available flavors. From the experiment manager dashboard, we can also open the SoftFIRE documentation that will provide useful information about the project, and in particular about the middleware and all the manager that is composed. Also we have some useful tutorial you can follow in order to get in touch with the platform and start creating your own experiment. From the left pane we have the reserve button that will allow us to upload our experiment. So we choose our experiment CSAR archive and we start uploading. The middleware will receive this experiment and will parse all the property. We can see the testbed destination, the resource name and all the other property. Clicking the deploy button will start the deploying process. The experiment manager will contact all the manager involved in the experiment. In this case we contact the NFV manager and the security manager. These managers will allocate and deploy the resource. We can see that the resources are reserved, and we can see from the status null that the actual virtual machine are in booting phase. That is, they are configuring the network and they are installing all the scripts necessary to our service. The booting time takes an average of 2 minutes in order to become active. We can see that the firewall gateway became active. You can see that we have some useful information. We have the local IP, the floating IP, and the credential used to log inside the firewall in order to configure it. Now we only need the server backend and the server frontend to become active. Now we can see that they are in active status. We can see the IP is a very simple service Following this URL, we can see a list of customers. Now we can use the IP address of the firewall gateway in order to get access to the local network, and we will try to enter the backend server in order to change some data from the backend. We SSH inside the backend server using the private key associated with the public key used in the experiment. Now we are on backend, and the service comprises a MySQL server, so we try to manually add some new row, and we will see the changes on the front end. Returning on the service front end, we can see that the new value appeared. Thanks for watching this tutorial. See you to the next SoftFIRE event.